Algebra 2 targets 7I can operate within the complex number system. Today, this video is going to focus on graphing the complex numbers and then finding the absolute value of complex numbers. All right? So as we look at it, we have such a thing called the complex plane. Now this should look pretty familiar to you. It looks a lot like the xy axis. And that's because it is a lot like the xy axis. The only difference, instead of calling it the x-axis and the y-axis, we have the real axis and the imaginary axis. And so as we have an imaginary number, we're going to graph the components, right? The real component will plot it on the real axis, and the imaginary component will plot it on the imaginary axis. So let's take a look at what we mean by this. We'll plot the complex numbers in the complex plane. So take a look at A. All right. Our real component is 3. So we can write this number as 3 comma negative 2i. Our real component is 3, so we'll go 3 over and 2 down. That is that number in the complex plane. For B, let's take a look at B. Our real component is negative 2, so we'll go 2 back, and our imaginary component is 4. So the number negative 2 plus 4i will be right there. Looking at C, that does not appear to have a real component. What number represents it's not there? Well, 0. So we could write this as 0, 3i. And so when we graph that, 0 on the real axis and 3 on the imaginary is right there. For part D, 4 or negative 4 minus 3i. Our components negative 4 on the real, negative 3i on the imaginary. So 4 backwards and 3 down is right there. So to graph numbers on the complex number plane, you take the real and you're going to put it on what looks like the x-axis. It's not, it's the real axis. And the imaginary, put it on what looks like the y, but is really the imaginary axis. All right? So it's just like an ordered pair. Real, comma, imaginary. Let's talk absolute value. Just like the absolute value is the distance a number is from 0, well, the absolute value of a complex number is how far it is away from 0. And on a graph, 0 is the origin. So if we look back on these, for letter A, the blue one, the absolute value would be this distance right here. How far is that point away from the origin? And like all distances, we're always going to be positive. The absolute value for B, how far is that away from the origin? Would be this distance there. For C, the absolute value would be this distance. And for D, our absolute value would be how far is that distance. We're going to have to kind of do some distance formula stuff. All right? If you take a look, what we got here, we got an imaginary number, A plus BI, right here. We can look at our real component here and our imaginary component here, and this is our absolute value. What shape do we have? Well, that is a right triangle. All right? So how do you find the hypotenuse of a right triangle? You're going to use the Pythagorean theorem. And if you remember from geometry days, Pythagorean theorem is what we use to develop our distance formula. And so that's why it's the square root of a squared plus b squared, because really you can kind of have your square there, but then we solve for z, and that's where we get the square root. So to find the absolute value, you're going to use your distance formula, which is derived from Pythagorean theorem. So let's look at an example. Find the absolute value of negative 4 plus 3i and negative 3i. So we can graph this out if we want to. I'm going to do a rough sketch. Negative 4 plus 3i will be right here. Our right triangle that develops will have legs of 4 and 3. So our absolute value here, our absolute value of negative 4 plus 3i, you're going to take the square root of our imaginary component, so negative 4 squared, plus our real component, 3 squared. And that's a 3, 4, 5. So our absolute value there is 5. So the distance from negative 4 plus 3i to 0 is 5. That's 5 units away from 0, so the absolute value of that is 5. Looking at B, how far is negative 3 away from the origin? Again, we can sketch it. You don't have to. You could maybe figure this out. So on the imaginary axis, we'll go 3 down. How far is that away from the origin? Well, that's 3 away. You can use your distance formula if you want to, but, absolute value, absolute value, negative 3i, because the real component's 0, 0 squared plus negative 3 squared. These are going to kind of cancel out, and you're just going to get 3. All right? So in conclusion, to graph a complex number, you're going to treat it like an xy axis, where you're going to put your real axis will be where the x-axis used to be, and your imaginary axis will be where the y-axis used to be, and you're going to plot it as an ordered pair. And then to find the absolute value, it's going to be the distance formula. A squared plus b squared equals c squared.